Hello friends, welcome. In this video I'm going to talk about deep copy versus shallow copy. So for the most part when we create a class, C++ compiler provides us for default copy constructor and assignment operators, which usually does a member-to-member copy, which usually means that for example, if we have a class, let's say class C, and then class C has a couple of members. I'll just say X and Y to keep it abstract. Now when we have when a copy of this particular object is made, let's say C1, a member-to-member copy means that the value of X will be copied to the corresponding object. So it will be X1 and let's say Y1. So it works for the most part, except when these X and Y are pointers which are pointing to dynamic objects. So let's see what happens in that case. So let's say if we have X and Y are and X is a pointer to a dynamic object. So when a member-to-member copy is made by using the default constructors, which is usually known as a shallow copy, the value of X will be copied to this object C1, which means that this new object C1 will have the pointer value copied. The address will be copied in X1, which means it's going to point to the same object. And let's say Y1 is just a regular integer or a string or some object which we have a new copy. Now the problem is that in this shallow copy, the new object C and C1, they are pointers. The member X is a pointer which is pointing to the same object, and that can create a problem when, let's say, we delete C, and in the process we also delete the pointer, the object to which X is pointing to. Now we have a valid object C1 which has a X1 which is a pointer, but the pointer is pointing to an invalid location, which is a problem. So this is the drawback of shallow copy. So whenever our objects have dynamic objects or pointers, usually we prefer a deep copy, which we have to do manually, which means we have to create our own copy constructor, which will do something like this. So let's say X is a pointer to an object. When we make a copy of this object C, what we will do is we will create a pointer X1 and we will make a copy of our own, and X1 will point to this new object. So this we have to do manually. So now this C1, the new copy, is completely separate, and it will have no effect even when the object C is destroyed and the corresponding pointer value is destroyed. So this is the concept that I'm going to talk about. So in the code, let's look how this looks like. You have seen this person class which has a pointer to pointer, which is we created a dynamic array of pointers, and in the constructor we created a dynamic array of this size. And now the let's say we want to create a copy constructor for course. So essentially, if you look at the diagram here, how this looks like is this. So let's say if we have an array, a dynamic array of pointers, which means these are all this array, let's say array, it has pointers to many objects. I'll draw them this side. So these are pointers to different objects. In our example, they are pointers to student or faculty objects. And let's say if we create a new array which is a copy of the previous array, if we do a shallow copy, the shallow copy will essentially be the new pointer will be pointing to the same pointer. So that doesn't work, because when this array is deleted, the previous all the pointers will be deleted, and we don't want that to happen. So the other option is that we create a copy of all the individual objects. So we create new objects. Actually, before we do that, there is another thing that may happen. If we do not implement the copy constructor properly, we could end up at pointing the objects to this existing copying just the pointers. But copying the pointers also is again not helpful, because for the reason I just mentioned, that if we have a copy of the pointers, then as soon as these the shared objects are deleted, then these pointers here are pointing to invalid objects, which is not a good idea. So therefore what we really want is this: when we create a copy of an object, what we want is we want to copy all the create new objects. And so what we will do is this: we will create new objects which are same as the existing objects here, and then we will have the pointers point to these new objects. Okay, so let's see this in code. So we have a person array, which is a dynamic array, and the called array, and the copy constructor, you know that it looks like this here. Copy constructor always has the same name as the class, and it takes we can add const later. It takes an object of the course type by reference. So we will say old object, and then it's always a good idea, because we are not changing the old object, to pass it as const. So this is the copy constructor for course class. This is a standard definition that we need to follow. Just the class name would change, but this is how the compiler identifies it as a copy constructor. And we have seen in the past how when the copy constructor is invoked, there are two specific situations in which copy constructor is invoked: during a function call, or when an object is created and an assignment is made on the same line. Okay, so now let's add the implementation for this, and add definition. So now this is what we need to do. First of all, we are creating a new object, so we need to set the size to the same size as the previous one, and then this dot count also equal to old object dot count. Okay, so now the first thing we need to do is create a new array. So this dot array, this is just, I'm using this here, although this is not required by default. It is there is no ambiguity, but this is just to make it symmetric and look clear, more clear. So we need to create a new person array of the same size, which is size. If you want, we can say this dot size, or size, just to keep it simple. It's clear enough. So we are creating an array of the new size, and now what we need to do is we need to create new objects of the same as the previous one, and then what we need to do is we need to point the array to the new objects. So now this particular example is a little more complicated than I would like, especially because this the person class that we have is actually we have base class. Person is the base class, and then the objects, the actual objects, are of student or faculty, which are the derived objects, and that's why it's not the best idea. It's a little bit more complicated, but I'll still continue with the example because it clarifies a few more interesting concepts here. So now we want to run a loop, so we can say for int I equals 0, I is less than count I plus plus. Now what we want to do is we want to replicate each object, as I showed here in the diagram. We want to create an object corresponding to each of these, and then we want to make the new array point to the new object. So for that, first of all, we have to find out whether well, we don't have the copy constructor for student objects. That should be fine, because the default copy constructor would be good enough, because we don't have dynamic objects or pointers here in student class nor in the faculty class. So the default copy constructor should be fine here. So what we need to do is this: we first need to create an object. And to create an object, what we need to do is we need to find out what type of object it is. What I mean is this: we say you know that array I is actually a pointer, and it has the type info, which is a character that we put here just for your clarification. We added a character type info, and this type info is set to F for faculty and S for student, so that we can find out which data type is this object belong to. So now what we need to do is this: if array type info is equal to S, then we need to create a student object, else we need to create a faculty object. Now I'm not foolproofing this code, because there maybe we have made a mistake and it's neither S nor F. For now we'll just assume that it's definitely either S or F. Now if array I, the existing, actually I'm sorry, we need to do this for old object dot array I, because new array is doesn't have valid pointers yet. So old object dot array I dot type info is S. Then we create a new student, so we create a student pointer, and we know that we need to create a new object, and array I is actually our object. Now array I is a pointer, and what we need is actually dereference the pointer. So we are actually using the object at array I. So that means the object here, we are using this object, not the pointer but the object, by dereferencing it, so that we create a new student object using this object. So it will invoke the default copy constructor of student class and create a new object here, and then we will have the array I for this new object that we have created point to the new object. So actually everywhere we have to make sure that we are using old object dot array I, and I'll use a parenthesis so that we are clear. So we are using old object dot array I is a pointer to a student object. We found that I using this S, and now we are dereferencing that to get the actual student object, and then we are creating a copy of that student object. And now I'll just call it student PTR, and what we need to do is now is this dot array I. This is the new pointer. So now we have created an object. So if we see it here in the picture, it's something like this. We just created an object which is same. I'll just use a different color. So this is a new object which is a copy of this object, and now what we want to do is we want this pointer to point to this new object. Okay. So therefore we are doing this dot array I equals student PTR. Okay, I hope this code is clear. I'll just type the same thing for faculty so we can see this again in action. So we are creating a faculty pointer which is a new faculty object, and what we need is an existing. So let's assume that this here is a faculty object. So we want to create an object which is exactly same as this. So we will use the dereferencing. So this is array, and I say this is old object dot array, and I is now 1. So we are using old object dot array I, and then dereference that pointer to get this object, and then we are creating a new faculty object this time, because this is we are using the faculty constructor, the default copy constructor of faculty class, and then we will say that now this is the new object that we are creating for course. So this dot array I, and we will point this dot array I to this new object. Okay, so new faculty, first thing we do is old object dot array I, and then we will put a parenthesis and star to dereference, so we get the actual object here, the actual object of faculty type, and then we will say this dot array I equals faculty pointer. Okay, so now this code should be clear enough, and we have copied the size and count, and then we have created a new array, and we have copied each object. So now in main, what I'm going to do is this: we have I'm going to create a new course, and I'll call it CS3303, and equals. Now we remember that we talked about which situations we copy constructor is called, and actually just to make things clear, I'm going to copy the debug code and say that course class copy constructor call, so we can see this in action, that we do have the copy constructor is called in this situation. So when we create a new object like we are doing here, and we use the assignment at the same time we use an existing object, that's when the copy constructor is invoked. Later on we will see in another video when we can actually create a overload assignment operator, and the assignment operator is a little different. It doesn't, this is not an assignment, this is, we are creating a copy of this existing object. And what I'm going to do is I'm going to print CS3, call print on CS3303, and to keep the output separate, I'm also going to cout. Okay, so now let's see, I build the code. Looks like we have some errors, and okay, so remember we did this earlier also when we created the objects. We the array is not a array of person, but it's an array of person pointers, so that's one error. And then I think the course class is not aware of the student class, so what we need to do is also include course and faculty classes. One repercussion of this is actually, if we want, we can remove this because a student class includes the faculty class or person class. Okay, now another thing is this: the dereferencing is, as you can see here, we have a person object, but the person when we dereference the pointer is of a person type, and the object that we are using is a student type, so that's why the compiler is not giving us a default copy constructor, or is not invoking the default copy constructor. So let's break this line down into two. So we will create a student object which is actually just from the old object. So old object dot array I, we know that this is a pointer to a student object. This we found out from here, that this is a student object. We know this. Now what we need to do, or a pointer to a student object, we need to convert this to a student object so that we can use this for in our code here. So we will, so that we can do something like this. Now to be able to do that, we need to do a static cast and to a student, and we will use this as we will dereference this and then use that object for as a student. Okay, so I think here the same thing is happening. It's here it's creating the new object. So let's do this. Here we will create we'll just change it to a student pointer. I think that's just easier. And so what we are doing is different now. So this is probably easier. First we will cast the pointer. This is a person pointer. We know that it's actually pointing to a student object. So we have seen this downcasting before. Now we are actually converting, if you recall this here, in another code that we wrote, probably in the main, not here, in another video we did downcasting, so we can see that we know that this is a student object, so we are converting to a student pointer, and then we will actually dereference this and say we are using old student pointer. Okay, so now this should be a pointer as well. So we are getting the pointer, just downcasting to get the pointer to the object, existing object here, but we are converting it to a student pointer and using that pointer or dereferencing that to get a new object using the default copy constructor of the student class. So let's build this. It should be fine. So now we can see the same error is in the faculty class, so we can repeat the code here. So first we create a faculty pointer, which is we will call old faculty pointer, and this is a static cast to a faculty pointer, and the object in question is the old object dot array I. And then when we create the new object, instead of using this directly, we will use old faculty pointer. Okay, so this I've broken this down. We could have done this in shorter, like we could have combined these two lines together, but I'm just keeping it simple here. So you can see here our code builds, and when I run this code now, we have person added at index I, at index 1, at index 2. When it prints 2 3 1 2 3. There are two student objects and one faculty object. We copy, course class copy constructor is called, and when we print the new object, we can see this 2 3 1 2 3. This is exactly same information. And another thing I would want to just to test our code, what we would like to do is this, that after we have printed and we copy, and before we print, I'm going to delete all the objects in the old course, so that we can see that we have not deleted the objects actually, otherwise we'll get a error. So here I'm going to run a for loop for int I equals 0, I is less than, actually let's do this later. I think I will create another video for showing you creating a destructor for the course class. Right now we don't have a destructor, and we are creating objects but we are not deleting them. Remember, we are creating actually we do have a memory leak here, because we are creating all these objects when we create the new array, but we are not deleting these dynamic objects. So we need to do this somewhere in the destructor, and so I'll talk about that in a separate video. So I'll pause here. Thank you.